All right, welcome back, ladies and gentlemen. So now let's get started into the last section of the limit. This is the limits at infinity. Now, the way I like to introduce this is going back to the beginning of the year when we talked about the end behavior of functions. So it's really nice to kind of end the year, with the last lesson and the first lesson having some connection. So if you remember at the beginning of the year, we talked about end behavior of graphs and we looked at them. And the question that we asked is, where's this graph going? As we expand to the right as well as to the left, where's the graph going? Up and down. We used some algebra 2 verbiage, rising and falling. And then we also looked into some mathematical notation as x approaches infinity, g of x approaches negative infinity. And I want you to make the connection now with that x approaches infinity and x approaches negative infinity, because that's exactly what we're looking for now. I didn't introduce the limit notation back then, but now we're much more familiar with those arrows and this idea of where is the graph growing as we are approaching. Now, sometimes the graph is going to approach infinity or negative infinity, but you can also see in these other functions, for instance, where there's horizontal asymptotes, you can see we're actually approaching a finite number. And that's exactly what we're going to be looking for. We will also use infinity as negative infinity where that graph is to expanding. And you can see in the first example, that's a polynomial. So, we definitely know this graph is just going to expand without bound. In part B, you can see that has a horizontal asymptote, so it's going to be approaching the horizontal asymptote. And that's as we're going to negative infinity as well as going to positive infinity. For part C, we also have another horizontal asymptote, so you can kind of see how that, again, is going to be approaching that to -3. In D, this is kind of interesting. We actually have a hole, but so what you can see, though, then is it's really a line, x plus 1, with a hole at x equals 3. So the graph is, again, going to continue with the end behavior of falls left and rises right. And then the other two I snuck in there, which was E and F. E, as you notice, is a square root function. So it's going to have one end behavior, but it's going to have an endpoint. So therefore, it's not going to expand as it goes to negative infinity. And F is a function that is going to keep on repeating. So therefore, we also talk about those do not have any end behavior. And we'll talk more about that as we get into our examples, as well as into notes of this section. So basically, the notation for the limits at infinity is going to be the exact same notation we talked about for the general limit, as well as left and right-hand limits. You can see that what we're looking for is x approaches infinity, as well as negative infinity. And even though L is the finite value, again, if it is approaching infinity or negative infinity, that is typically going to be the preferred answer that we will be using. So we're just going to look at evaluating the limits at infinity, as well as look at evaluating limits at negative infinity. So all you got to do, guys, now is go ahead and take a look at the notes, get started with the practice problems, and give the quiz a shot. I look forward to seeing you in the next video.